Let's have another go on the integration by substitution. Okay, this is mainly exercise. What exercise it is? 8D of this page P3 book. Okay, I'll be solving some of the questions from here. This fourth question. Acha, now please see this. We have here. We have to solve. We have to find the exact value of this integral, which is from 0 to pi by 2, and this is cos cube x dx, and there is the substitution given, that is u equal to sine x. You must see that this cos cube x is something that we are really unable to integrate this directly. Therefore this substitution is being used uh, so that we are able to integrate this trigonometric function. ठीक है अच्छा. Now first of all, the substitution given, that is sine x, but you have here cos cube x. Okay, so we'll have to see this, that this u square is going to be sine square of x first of all, because the identities that help us to switch between the sine and cos, these are basically they start from this fact that the sine square x plus cos square x, that is equal to 1. So we have to have a square on it. Okay? So you can write this u square as 1 minus cos square x, and then this cos square x is going to be 1 minus u square, and then your cos x is going to be the square root of 1 minus u square. And then if you want to have the cos cube, so you cube both the sides, so this can be written as 1 minus u square raised to power 3 by 2, or a cube, and then you can put the square root on it. So I'll start, let me name this as I. So I'm going to write this first of all as 1 minus u square, and then there is the power 3 by 2. So we have found the substitute for this cos cube x in terms of u. Okay? The next is that we have to think about this this dx over here. Okay, so let's differentiate this with respect to x here. This is going to be du by dx, and that is going to be cos x. And then this dx cos x is going to be equal to du, and your dx is going to be du over cos x. Okay, so you have this cos x over here. You can use this. So this dx is going to be purely in terms of this u. Okay, so this will be written as du over under root 1 minus u square. So I'll be writing this here, du over under root 1 minus u square. So all this expression is now in terms of u. We have to change these limits as well. Okay, these have to be according to this substitution. Okay, so I'm going to cover this up here, and let's change this into the u. Okay, now we have u equal to sine x. So when your x is 0, your u is going to be 0. When your x is pi by 2, so your u is going to be sine pi by 2, which is going to be 1. So the limits are going to be from these are the new limits we have from 0 to 1. Okay, this is from 0 to 1. So all are integral. Now it is purely in terms of u. I can cancel out this under root 1 minus u square with this, and like the power 1 would be left here. So all we have to integrate now is for the limit from 0 to 1. This is 1 minus u square du. This is very much in your hands. Now you can easily integrate this. Okay, let me cover all this up now. So we integrate this with respect to u. There is no need to go back into the x form here because we have the limits here. Okay, so this I is going to be now in, like, this is going to be integrated. The integral of 1 is going to be u, and this is this u squares integral is u cube over 3. You put the limits in here. This is 1 minus 1 over 3, and then when you put 0, you get this 0 here. So your exact value of this integral is going to be 2 by 3. Okay. Acha, now for the smarter students, you see that you could also this is just an alternate method here. You were given this substitution that u is equal to sine x. Okay, so some smarter kids may do it like this. This is going to be cos square x, and then you have cos x dx. See, uh, this will be directly changed into 1 minus u square, and you have seen that if you find this du by dx here, du by dx, that will be cos x, and this will be cos x dx. Okay, so this would simply become du over here and limit from 0 to 1. So this is for some students who are really cleverer than the others, so they can change this into cos square into cos x. But nevertheless, you can go simply the way I have explained. You find the substitution for cos x in terms of u as I told you, and then you can proceed. Okay. Now let's go on to this B part here. In this B part, we have under root x over, thank you. Okay, this B part says this is, let me name this as I, this is limit from 0 to 4. This is under root x over 3 minus under root x dx. Okay. And the substitution is u equal to 3 minus under root x. Okay? Okay, so this 3 minus under root x in the denominator would directly be written as u here. And you can see that under root x can be, your under root x can be 3 minus u. So you can write here 3 minus u. And then for this du, you can find this du by dx from here. This is going to be minus 1 over 2 under root x. So this will give you, this is going to be du that is equal to minus 1 over 2 under root x dx. Okay. And if I had not changed this, I could have easily got them cancelled. But anyhow, we can write this as this dx is going to be minus 2 under root x, and then you have du. Anna, this is du over here. I think we could not cancel this out. Okay. Okay, so I can change this under root x with this 3 minus u here. So my dx is going to be uh, minus 2 into 3 minus u du. Anna? I just changed this under root x with this 3 minus u. So I have this 2 into 3 minus u and times this du. So I'll be writing this minus 2 over here. And you see this 3 minus u into 3 minus u will make it a square here. And then you have this du. Okay? Now let's think about these limits here. So we have this main thing here. So when your x is 0, your u is going to be 3 minus 0, that is going to be 0. And when your x is going to be 4, your u is going to be 3 minus under root 4, Hannah, and that will give you 2. So this is going to be 1. So the limits are going to be from 0 to 1. Okay? These are the limits that you have here. Okay, now let's see. Now all this integral, your integral is purely in terms of u. Now that is the first task of your integration by substitution, that you convert all your expression, your integral in according to, you change that according to this given substitution. Okay? Acha, now next let's now try to solve this. Okay, so chale. So this integral is going to be minus 2 limit. Oh, I can't integrate this right now. I need to expand this. So this will be 9 minus 6u plus u square over u. Okay, and I can then split this up. Minus 2, limit from 0 to 1. And this is going to be 9 over u. This is minus 6. And this is going to be u. Okay, now we can integrate this. Yes. So this will, let me have some space here. So this is now going to be minus 2, limit from 0 to 1. This is 9 ln u. Okay. And then we have minus 6u plus u square over 2. U square over 2. There is a problem. There is a problem. I had to go back to check where is this. Look at this. When I put x equal to 0, this u is had to be 3. Anna, this was 3 minus 0. Anna, you didn't notice that. So this had to be 3 over here. Sorry, not here. Here. It has to be 3. It has to be limit from 3 to 1. So this is where we were making a mistake. I thought I have done something wrong here. Okay. So we need to go back to our working now. So I'll now correct this accordingly. You see, here was a problem. I made a careless mistake while correcting these, finding the new limits. Okay? So let me do that again. Sorry for that careless mistake here. So this was minus 2, limit from 3 to 1. And this is 9 minus 6u plus u square over u du. You see, why did I stop there? Because, I was getting 9 ln u. Can I put u0 here? क्यों भाई? ln 0 is an undefined thing. So that was the problem here. That is why I had to check all my working. ठीक है? अच्छा, one more thing here, Waleed. If I change the sign of this minus 2, if I write this as 2, you see these limits will be reverted. You must be knowing this fact, okay? So I have, because normally the limits go from the smaller to the bigger. So it has to be limit from 1 to 3, okay? So now this is going to be 9 over u minus 6, and this is absolutely fine here. So now we can integrate this. Okay, so I have here finally, this is going to be I2 limit from 1 to 3. This is 9 ln u minus 6u plus u square over 2. And we put in the limits here. This is going to be 9 ln 3 minus 18 plus 9 over 2. And when I put 0, ln 1, that is 0. Okay, let me write this as 9 ln 1 minus 6 plus half. Okay, so this is going to be 9 ln 3, and then you have, this is 4.5, and this is minus 13.5, and this is going to be 0. This is plus 6, this is minus 5.5, and this is going to be plus 5.5. So you have 2 into 9 ln 3, and you have minus 8 here. Yes, minus 8. And you can write it as 18 ln 3 minus 16. Let's try one more question. That is going to be the D part. Okay. Okay. So here we are. The D part says we have limit from 0 to under root pi. And this is 2x. And this is cos. We have such a weird angle here. This is dx. Okay, this is your I here. And we have been given the substitution, which is, let me write it here, u that is equal to cos x square over 4. Okay, I'll just wait before I'm quite sure that this cos x square over 4 will be changed with the u, but I'm sure I'm going to get 2x when I differentiate this, and that will be covered 2x dx. That will help us to write here the things in terms of u. Okay, so let's find du by dx. So that will be minus sine x square over 4, and then the derivative of this x square over 4 is going to be 2x over 4. That will be x over 2. Let me write it as it is, 2x over 4. That is your du by dx. Okay, so this means that we have another problem here, that is the sign. We'll have to look for the substitution for this sign here. Okay. Now, can I say again, as we know we have this here. So if u is cos x square over 4, then can I say sine x square over 4 would simply be under root 1 minus u square? Yes. As for example, if I do this quickly, your cos square x minus 1, that is going to be your sine square x, and sorry, 1 minus cos square x, sorry. So this is your, I wrote it wrong here. So we can say that because I'm looking for the sine thing. Okay, so this sine square x is 1 minus cos square x, and then your sine x is under root 1 minus cos square x. So if this cos x was u, then the sine x would be under root 1 minus u square. So similarly, the sine x square over 4 is under root 1 minus u square over here. I have done this in this part A as well. Okay, so yes, so this is going to be, this du is going to be minus sine x square over 4 2x over 4 dx. Okay, 2x over 4 dx. Okay, can I write this as 4 du? Okay, 4, this 4 goes here, 4 du over this minus, instead of this, I'm going to write under root 1 minus u square. Okay, and I'll keep this 2x dx because I have this, look at this, I have this 2x dx here. Okay, so let me write it here now. I'm writing this minus outside here. In fact, this minus 4 outside here. And for this, I will be writing u. Okay. And then I have this under root, for this 2x dx, I have this du over under root 1 minus u square. Oof. Oh, okay. So then we have to change the limits. We have this u equal to cos x square over 4. So when your x is 0, x is 0, your u is going to be, cos 0 is 1. Okay, so the lower limit is going to be 1 here. When your x is the square root of pi, then your u is going to be cos pi by 4, which is basically under root 2 over 2 or 1 over under root 2. You can write this under root 2 over 2. Okay, this is under root 2 over 2. Okay, I'm going to stop here because this simply goes out of the bounds of your syllabus here. You see that you will have to again think of another substitution. Let me show you. This has become a question like A question like, let me show. This should, this is just like a question like this B part, okay, where you're substituting this 1 minus 2x squared as u. And let me give you a hint. You will now have to substitute. This is clearly out of this the bonds of your syllabus, okay. Let me show you what is going to happen next. You see, Waleed, here, you will have to say, okay, let this 1 minus u square is, let us keep it as y, okay? So your dy by du is going to be minus 2u. And then your dy is going to be minus 2u du. Okay? Acha, I'm not changing the limits. I'm just telling that what is going to happen here now. um, if I move this minus 2 here, okay, so this is u du. Can I write instead of this u du this minus 1 over 2 dy? You already have a minus 4 here.
Yes,
This
sir.
will be minus 2, and this is going to be dy, and you have here under root y. That's it. And you will have to change the limits as well. Look, when you put your u as 1, when you put u as 1, your y becomes 0. So the lower limit is 0. When you put your u as under root 2 over 2, that becomes 2 over 4. है ना? When your u is under root 2 over 2, then your y is going to be 1 minus 2 over 4, 1 minus half. This is going to be half. So this is limit from 1 to half. Oh my goodness. Look at this, the scale of this question. Now this is 2 2s are 4. So finally this question has now become, I have completed this question, by the way. So this is going to be to limit from 0 to 1. And I'll move this under root y up here. This is y raised to minus half dy. I'm telling you again, this is out of the, like, the approach of your syllabus. Okay? So you don't worry about this.
Sir, the isn't the limit half?
Oh, yes, this was half. Thank you for that. This is half. Okay. So y raised for half over half. Okay. This gives you 4 into the limits 0 to, I think that was 0 to, yeah, this is 0 to half. Okay. And this is going to be under root y basically. Okay. So this is 4 into the square root of half. That's it. Okay, this is 4 over under root 2. And if you rationalize this, you must get 2 under root 2. Now, one thing that that is a good news for you, that whenever you will be having a question on this integration by substitution, this substitution has to be given. So you will not have to think yourself that what should be the substitution. So at this point, I'm going to finish this segment here. Thank you very much.